Hey everyone, in this video we're going to talk about some trig functions. We'll talk about the functions, angles, and some fundamental identities. So first let's define our 6 trig functions, and these are going to be based on an angle that we have that we create with the origin being at the vertex of the angle, and then we have our initial side of the angle on the positive x-axis. And so if we sweep out an angle, we're calling it theta in the counterclockwise direction, and then our terminal side of this angle is just wherever we decide to stop for this angle theta, and then we measure out at this radius r, okay? And then we create a right triangle. So here's what we need. Once we have the angle theta, we need some distance r. Using the distance formula, we can get an equation for what r would equal. And it's based on the sides of what we've created here with this right triangle. So it's based on sides x and y. And so we have a right triangle here, and if we know this adjacent side and this opposite side, we can use that to find this longer hypotenuse side. And then we can define our 6 trig functions using those values. And so we have sine is y over r, and then cosine is x over r, and then tangent is y over x. So let's just talk about those 3 first. So thinking back to our picture here, we created this angle just from sweeping out theta, whatever theta happens to be right here, and then we made a right triangle with this. So from there we said, okay, here's our right triangle, and we have this height of this triangle is y, and then this length or base is x, and then you can use Pythagorean theorem to find r, or distance formula, and then just those numbers we use in our trig functions. So the opposite side, y, divided by the hypotenuse r, is our sine value, and then cosine is the adjacent side over the hypotenuse, and tangent is the opposite side over the adjacent side. And so you can say that SOHCAHTOA, it's an easy way to remember it. So sine is the opposite side of the triangle over the hypotenuse. Ka is cosine. So cosine is the adjacent side of the triangle over the hypotenuse. And then TOA, tangent, is that tangent is the opposite side over the adjacent side. So when I say opposite, adjacent, and hypotenuse, well, hypotenuse is always the long side, the opposite of the angle. So this is our outside angle, but our reference angle would be here. So we say opposite of that angle, that's this side there. And then the adjacent side would be the side touching it. So that's what I mean by opposite and adjacent. And then the other 3 functions are just the reciprocal of the first 3. So cosecant is just r over y, the reciprocal of sine, and then secant is the reciprocal of cosine, so that's r over x, and then cotangent is the reciprocal of tangent, which is x over y. And each of these have moments on your angles where you don't want to plug in 0 for certain values, because it would make the function undefined. So for example, anytime that y would be 0, you wouldn't want to plug that into your cosecant function or also your cotangent function, because then it would be undefined. Alright, so let's take a look at this example. We don't actually know what this angle value is, but we know that the terminal side of this angle goes through the point -3, -4. Okay, so regardless of if we know what theta actually is equal to, we just need to know a point on the terminal side of that angle, and from that alone we can find the 6 trig function values. So we know that if x is -3, then this adjacent side of the triangle here is -3. And then if y is -4, then we know that this opposite side of the triangle is -4. And so from those 2 we can find the hypotenuse. So we can figure out that the hypotenuse should be 5 by using our distance formula or the Pythagorean theorem. And so from there, if we just identify x, y, and r, we can plug those values into our 6 trig function definitions, and then get all 6 values. So we'll just take a look at a few of them, but they're all here. Remembering that sine is the opposite side over the hypotenuse, so opposite side would be y, the hypotenuse would be r. For us, for this particular problem, that's -4 for y and 5 for r, and so that's why the sine value of this angle is -4/5. And then you can do that for all the other functions. And then taking a look here at cosecant, you can actually just use the fact that it's a reciprocal of sine. So you could say that cosecant is r over y and plug those values in, because r is 5, y is -4. Or you could just look at your result from sine and flip that over, find the reciprocal to get the cosecant values. Alright, so just something to mention here, we can find the 6 trig function values by using any point on the terminal side of the angle. So when we're talking about our unit circle, we are picking a point that's a distance of 1 unit away. So for example, like let's say this was the point here on our terminal side, 1 unit away for distance, and that's how we use our unit circle, because it's a circle with radius 1 centered at the origin. And so we could do any point that is useful for us. And so for the next example, you'll see why this is a thing to consider. So find the 6 trig function values for an angle theta in standard position. The terminal side goes through this equation. Okay, so all we really know is the equation of the line that would give us the terminal side of this angle, and we don't even have any points yet. We'd have to actually find them. And so what we can do is we can consider that line, and you can draw it. So I have a picture of it here. If you want to put it in slope-intercept form, you could say 2y equals -x, and then if you divide by 2, you would say y equals -1/2 x plus 0. And so that would be a line going through 0, 0 with a slope of -1/2. Okay, so that's how you would get this terminal side of this angle. That's that line there. Okay, so once you know that line, you basically can pick any point that's useful for you, like maybe an easy point on the equation of the line, and we're going to pick 2, -1. So how you could get that is just by choosing a number for x and plugging in and finding y. So if you just choose x is 2, plug that into your equation and you'll find y. So your ordered pair, or your point on the terminal side, is 2, -1. And so when you have your terminal side of your angle, so the angle basically sweeps through like this until that equation of the line that creates the terminal side, and there's that terminal side of the angle. The initial side would be here, and so the reference angle would be right here, and then you're creating the triangle with some point on this terminal side. So we chose 2 for x, we found y is -1, and so we know that if x is 2, this distance is 2, this adjacent side, and so this height here, or this opposite side, would be -1 for y. And then that's our triangle here, and then you can use our distance formula or Pythagorean theorem, and you would get that the radius or the hypotenuse is √5. So now you have all of the values that you need to plug into all of the 6 trig function definitions to find their values, knowing that x is 2, y is -1, and r is √5. So you plug those in, and then you can find all 6 trig function values. Alright, so now that we have a nice foundation for our trig functions and their definitions, let's get into some details about them. So this is a table of the function values for what are called the quadrantal angles, and those are just these angles here that land on an axis, an x or y axis. So visually, if you were to look at your unit circle centered at the origin, or any angles really that you have your initial side on the positive x-axis, if your terminal side lands on one of the 4 axes, so on positive y, negative x, negative y, or back on positive x, those are your quadrantal angles. So 90 degrees, or 180, or 270, and then back at 360, that's also 0 degrees. So So just the trig function values at those angles, and you can see, just thinking about the coordinates of these points, if we're on our unit circle, this would be the point 1, 0. We're 1 unit away from the origin. And so if we think about that for, let's just do some of these, sine is opposite over hypotenuse. And so the opposite side, or the height, is 0, so 0 over 1. And then the cosine is the adjacent side over the hypotenuse, and so that would be 1 over 1, and so that's why that value is 1. And then let's just look at cotangent. Cotangent is undefined because cotangent would be x over y, and then in this case x is 1 but y is 0, so we'd be dividing by 0 there. So just taking a look at how you would find those trig function values of your quadrantal angles. Next is the reciprocal identities, and we've been using this fact already, but here's just a nice layout of all 6 of these and how they are the reciprocals of each other. So sine, we know, is the reciprocal of cosecant and vice versa, and then cosine and secant are reciprocals, and then tangent and cotangent are reciprocals. So basically, if you know one of the values, then you can find the reciprocal value in that function just by flipping over the quantity. So now let's use the reciprocal identities, and we're going to find cosine given secant. Okay, so we know secant's value, secant of theta, and we want to find cosine of theta, and we do know that cosine and cosecant are reciprocals, so we can use that fact. We're trying to find cosine of theta. We know it's 1 over secant of theta. If we know the secant value, we just say 1 over that value, and then it's a fraction inside of a fraction, so we flip and multiply by the reciprocal, so we say 1 times 3/5, and so cosine, knowing what secant was, we can easily find that value. So how about for sine? So we're given cosecant, we want to know what sine is of that same angle, and these are also reciprocals of each other. So because sine is the reciprocal of cosecant, it would be 1 over our cosecant value, so we would just say 1 over this negative square root 12 over 2, and so if we flip and multiply, we end up getting 1 times negative 2 over square root 12, and then that's the result. Like, that is the answer, but we usually don't leave answers in this form where we have a radical in the denominator, and also if we have a radical that can break apart, we usually do simplify it. So the 12 can be rewritten as square root 4 times square root 3. So first we could just say that that's 2 square root 3. And then we tend to not leave radicals in the denominator, we rationalize them. So we'll multiply top and bottom by a square root 3. And then that way, the square root 3's on bottom can turn into a nice whole number 3. And then we just end up with square roots on the top. So our final answer here, even though we had an answer way back here, we can say that this is a more structured answer, a negative square root 3 over 3. Next, let's talk a little bit about the ranges of our trig functions. So these are the values that will possibly come out of the function. And so for sine and cosine, the range is between -1 and 1. So any of your values that you get out of that function, whatever angle you plug into it, theta, you will always just get as big as 1 and as small as -1. And tangent and cotangent, those can actually take on any value. So you can get any numbers between -infinity and infinity for tangent and cotangent. And then secant and cosecant, because those are actually the reciprocals of sine and cosine, think about how that affects the range of those functions. You'll get any numbers less than -1 and then any numbers bigger than 1. So pretty much like the opposite of what sine and cosine do. So now let's just say an example to decide whether each statement is either possible or impossible. So not knowing what the angle theta is it even possible for sine of some angle to equal square root 3? So we just talked about that sine will only be values between -1 and 1. So square root 3 is about like 1.7, and so that's more than 1. So no, it's impossible. There was no angle theta that would ever give us this value of square root 3 when we plug it in for sine. How about for some angle theta, tangent is equal to 110.47. Well, if you recall, the range for tangent is any real number. So yes, this is completely possible for any angle. There is some angle that we can plug in to tangent where the value would be 110.47. Then how about this one? Secant theta is equal to 0.6. Well, remember secant is the reciprocal of cosine. So if cosine's range is between -1 and 1, just think about it like this. So if cosine would be between -1 and 1, the reciprocal is secant. Those values would be less than -1 or more than +1. Okay, and so I'll just put 0 in here for reference. So secant equaling something between -1 and 1 won't actually ever happen. That's impossible. So next we're going to take a look at some identities. First, the Pythagorean identities. So we've seen this before, but these are the Pythagorean identities that are very useful. They come up often with our trig functions, but we start with just this one. Sine squared plus cosine squared equals 1. And you can get the other two from this. So you don't have to necessarily remember or memorize all three of these if you just know the first one. So I'll show you how you get the other two. If you take the sine squared, divide that by sine squared, you do that to all three parts of your original Pythagorean identity. So let's just divide everything by sine squared. You get 1, and then cosine over sine is cotangent, so that's cotangent squared here. And then 1 over sine is cosecant. So that's how you would get this other version of your Pythagorean identity. And then if you divide everything by cosine squared, so cosine squared theta, then what you'll notice is you'll have sine over cosine, which is tangent, so that's tangent squared right here. And then cosine over itself is 1, and then 1 over cosine is secant. So secant squared. So this is the other version of the Pythagorean identity. So as long as you know the first one, sine squared plus cosine squared equals 1, you can find the other two. Here are the quotient identities. And so sine over cosine is actually equal to one of your other functions. It's equal to tangent. And then if you flip that over, because you know cotangent is the reciprocal of tangent, then cosine over sine is cotangent. So here's just a little bit of reasoning for how that happens up here. And so, but we can always actually rewrite tangent in terms of sine and cosine. Same thing for cotangent. So let's try this example. We're going to find sine and cosine knowing that tangent is 4/3. Okay, and then we're also told that the theta is in quadrant 3. So the quadrant is to tell us whether or not cosine and sine will be positive or negative. So since we're in quadrant 3, think about that if you're on your xy plane. So x is here, a positive over there, but it would be negative over here. And then up here y is positive, but then down here the y values are negative. So if you're in quadrant 3, cosine and sine will both be negative. And then you can use the quotient identities, or you can use one of your Pythagorean identities. So I'm going to actually just use one of the Pythagorean identities just to show you how. So we're going to use the identity that involves tangent because we want to use what we know. We are given the tangent value. Again, you could use your quotient identities, but I'm just showing you how to use a Pythagorean identity. So you plug in what you know. We only actually know this one value, that tangent is 4/3 for angle theta. So we square that because this is tangent squared. So we want to say 1 plus 4/3 squared, and we know that's equal to secant squared from the identity. So if we square this, we're going to get 16/9. If we add 1 to that with the common denominator, so 1 plus this, we would have 9/9 for a common denominator. And so we would get 25/9, and that's equal to secant squared. So if you take the square root of both sides, then you can get secant. And so you would say plus and minus square root of this, and that would be 5/3. And we are going to take the negative because we are in quadrant 3 and we want a negative cosine and sine, or x and y value. So we know that this is negative 5/3, and that's our secant value. And so if that's secant, the question was what's sine and cosine, and so secant is the reciprocal of cosine, so if we just flip that answer over, we already have our answer for cosine. So negative 3/5 would be our cosine value. And then we could, from here, use the quotient identity to find sine. We could also draw a triangle here to find sine, quadrant 3. But I'm just going to use the other Pythagorean identity to show how to use it. So we know the cosine value now, and we can plug it into our Pythagorean identity. Notice I just solved this one for the unknown. So it's still the identity sine squared theta plus cosine squared theta is equal to 1. But if we just subtract cosine squared from both sides, then we have this format where we can solve for sine squared. So plugging in cosine, we know that's negative 3/5, and squaring that, and then you get 9/25, and then 1 minus that, so as the common denominator, that would be 25/25 minus 9/25. And so we would get sine squared is equal to 16/25. And if we take the square root of both sides, we'll get sine. And remember, we are in quadrant 3, so we're going to take the negative value, and so sine will be negative 4/5. All right, for this one, we're going to find an expression for one of our functions in terms of another one. And sometimes we need to do this in math. And so we're going to find an expression for secant theta in terms of sine. Just so you know, like in calculus, this happens often when we need to do like integration. We rewrite one of the trig functions in terms of another one. And so we're going to use the Pythagorean identity on this one because it is a relation between sine and cosine, and we know that secant is the reciprocal of cosine. So we choose this identity because it involves two things that we need, sine and cosine. And then we're going to just start solving for cosine because secant is the reciprocal of that. So if we just subtract sine squared from both sides, we get sine squared equals 1 minus sine squared. And then we'll take the square root of both sides, and then when we do that, we take plus and minus, and then we consider if we want to keep it plus and minus or just pick one of those signs. And so secant is equal to the reciprocal of this. So now let's consider the fact that this angle is in quadrant 4. And so secant is 1 over cosine, and so secant would be positive in quadrant 4 because in quadrant 4, x values are positive. And so we would say secant theta is 1 over square root 1 minus sine squared theta. And then if you just rationalize this expression by multiplying both sides, or both top and bottom, by the denominator, 1 minus sine squared theta, top and bottom, then you will get this final answer over here where we have the square root on top and then the expression without the square root on bottom. Alright, let's take a look at one last example here. So this one is an application for our trig functions. This has to do with the grade of a road, like its steepness or slope. So a downhill highway grade is modeled by the line y equals negative 0.06x, and this would be in quadrant 4. So visually we have this picture here where the line can be found by that equation, and that would represent this road with the downhill grade. So we want to find the grade of the road and then also approximate the grade resistance using this formula. So the grade of the road it's the steepness, so it is downhill, so it's going to be a negative value. And then for every 100 feet, if you plug in 100 feet horizontally, that would be like for x, and then you multiply it by the slope, negative 0.06, you end up getting that we decrease by 6 feet for every 100 feet of a horizontal input. And so therefore the road grade is negative 6%. Okay, so that's the grade. And now the grade resistance for a 3,000 pound car, we're going to use the formula that's given. So we have that the formula is the weight of the vehicle times the sine of the angle. Alright, so for sine of the angle, we know that sine is y over r, or the opposite side over the hypotenuse. So we can use the fact that this is negative 6 as the opposite side, but we do have to calculate the r value, or the hypotenuse of that triangle. So just using the distance formula or Pythagorean theorem and plugging in our values for x and y, we can get that that hypotenuse would be square root 10,036. And so if we divide those, then we know that that value is equal to our sine of theta. And then the weight of the vehicle, we multiply that by sine of theta, and we get that it's negative 179.7 pounds. So basically what that's saying is that gravity will be pulling that 3,000 pound vehicle downhill with that amount of force, with about a 180 pound force. And so the downhill grade is going to give you negative resistance because it's pulling it downhill. Alright, that is it for this one. Thank you for watching.